we'll go. Question 4. Jeremy is planning a long weekend break during which he wants to photograph as many different churches as he can. He'll start from his home on Friday morning and return to his home Monday evening. Table 1 below summarises the routes he can take each day and the number of churches that he will pass on each route. You may assume that the 28 churches in the table are all different. Represent the information in the table as a directed... another little bit of highlighting. It's highlighting crazy going through this. What does the word directed mean in front of a network? It's got arrows on it. Okay, so there have to be arrows on the arcs because it's a directed network in which the vertices represent the places. You may code the place names using the letters as above. Very generous. Right. So, for our first mark, I am... how am I going to do this with the... Well, you've got the table in front of you, so I'm going to go onto a new page and do it with the table that's in my hand here. Thinking through what we're doing. So he's starting from J, his home. So we're going to start with J. And on the first day, it says he could go to Caton or Little Elling, K or L, and there are 4 or 5 churches. So let's draw our arc to those 2 places. We've got K or L, and actually I'm going to put that and make it that. And these are directed, of course. And that one was 4, and that one was 5. Okay, then from K. Now on Saturday, on our table here from Saturday, from K to M and N. But from L is also going to go to N and P. So we've got M, N and P. We're going to put them as the next stage in our drawing. M, N and P. And M, N. And this one goes to N and P. So there is our network, and I've put all of them in one place again, but it will be alright. There we go. Arrows on them. K to M has 2 churches, K to N has 0, L to N has 0, L to P has 4. Right, next day, Sunday. And we've got M, N and P as the start points, the from places, and we're going to R, S and T. Now M and N are both going to R, so let's put R there. P is going to S and T. So let's draw in our arcs. So we have M to R, we have N to R, we have P to S, and we have P to T. And that, I think, is all that we've got marked on that one. They are directed, so let's put our arrows on there. And these are 0, 4, 3, and 2. And then finally, and this is where some of us went wrong, he's going back to Jeremy's home, but it's not looping back. He's ending up back at Jeremy's home. It doesn't matter that it's the same place. It's the final stage of the journey is to return home. So we've got J over here, and we're going to draw our lines to J. And they end with 4, 0, and 0. 0. It's quite important that quite a few people had this looping round the start point. It's all about context, isn't it? And in the context of the question, it really doesn't matter that he started and finished at the same place. It's the stage of the journey that it's all about. It's getting there that's the important thing. Okay. Right, brilliant. Well, we've got that now. Then it says, Jeremy wants to use dynamic programming to find the route he will pass the greatest number of churches. The state variables will represent the places where he stays overnight. J will have state variable 0, 0 at the start of the journey. The the table shows the stage state variables for all the places. I actually took a moment at this point to reassure myself that my answer to part 1 was right, and also to get that information onto my diagram. So I used that little table that was printed there with the stage state values to allow me to update my table. So let's put those on as well. So that J is 0, 0, isn't it? K is 1, 0. L is 1, 1. M is 2, 0. N is 2, 1. P is 2, 2. And notice how I'm feeling really reassured that I've done everything right so far, because this is all in the perfect kind of order. And T is 3, 2. That makes J 4, 0. Okay, so we've got everything labelled. Set up the dynamic programming tabulation, working backwards from Monday to Friday. This was Monday. To find the route that Jeremy should take to pass the greatest number of churches. Write down Jeremy's route. You may code the place names using the letters as above. Write down the number of churches that you'll be able to photograph on this route. Right, so it's not uncommon for us to start without any kind of framework for our dynamic programming table. So we've got to remember what the headings are for our dynamic programming table, because otherwise we're going to miss out some columns and it will go wrong. So when we do dynamic programming, we want stage, state, action. They're the key things, aren't they? They're the big things we need. We then have a working column. Remember, that's the column in which we don't do so much on a minimising or maximising one, but when we're doing a mini-max or a maxi-min, that's the min of the two values column. And we need a last column which we called suboptimal maximum. That's the bit where we're going to record what the maximum is so far. That's our initial tableau, our dynamic programming table ready to go. Is that line horizontal? Good, thanks. You think no? I think it is. It's lining up with the pixels. The pixels are on my side. Right, so when we start this, now, remember, we don't start with stage 4. Because stage 4 has nothing going on, that's the end of it. We start with stage 3 and thinking about what happens as we get from stage 3 to the end. So we're starting with stage 3 in here. Because I'm going to have to keep going up and down, I'm actually going to switch to having my network diagram here so that I can refer to that. So stage 3, I am going to refer to it a bit though, has 3 states. States 1, 2 and 0, 1 and 2, and all of them each have only one action. The action is a 0 action that takes us to the 4, 0 point. So we have 0, 1 and 2, each with action 0, and they have values. The values that they have are 4, 0 and 0. And it's really dull in this first stage, isn't it? Because there's nothing really to write. That is our suboptimal maximum. That's it. That's the end of the first section, so we can rule off underneath that and move on to stage 2. So remember, you always start your tableau not with that stage, but you start with the stage that leads you to the final one, so that you've got your first set of actions in there. Our next one is stage 2. And we have state 0, 2, 0, has only one action, and it's action 0. because it takes us to 3, 0. So we have 0, we have action 0, and that action has a value of 0, and action 0 from this one, or state 0, had a value of 4. So we have 4 coming out of that. And that's it. That's the end of that first state in stage 2. You sometimes would rule a line off there. We're going to record that suboptimal maximum in a moment. We've then got state 1. And state 1 also has only one action. It goes to 0. So state 1 has has one action which goes to 0, and that action has a value of 4, which we're going to combine with the suboptimal minimum from the previous one, which is also 4, which gives us 8 there, and ruling off that bit as well, because that's the end of that state, and it takes us to state 2. State 2 has two actions, actions 1 and 2. And actions 1 and 2 have values of 3 and 2. And 1 and 2 from up here had values of 0. So we're adding 0 to each of these, giving us 3 and 2 there. Before I leave this this second stage of my diagram, I'm going to fill in my suboptimal maximums of being 4, 8 and 3 so far. We rule a line underneath that one, and we're ready to move on to stage 1. Stage 1 has only two states in it, 0 and 1. So here we're in 1 with 0. 0 has actions 0 and 1. They have values 2 and 0. And this is where we add on the previous bits. And so the 0 one up here was a 4, and the 1 here was an 8. That gives us 6 and 8. And then we've got state 1, which has actions 1 and 2. So we've got 1 here with, I've done it again. 1 here with actions 1 and 2, which have values 0 and 4. And the 1 suboptimal maximum from the previous stage was 8. The 2 one was 3, which gives us 8 and 7. At which point I'm going to identify the suboptimal maximums again. We have a value of 8 there and a value of 8 there. And I'm going to rule off underneath that. Ready for stage 0. Stage 0, obviously stage 0 only has one state, it is state 0. But that had two actions. Actions 0 and 1, taking it to 0 and 1 in the previous stage. And we had values associated with those of 4 and 5. So that 4 plus 8, and that 5 plus 8 gives us 12 and 13. And 13 is the suboptimal maximum. And that is a perfectly laid out table for that bit. But that's not the end of our answer, because the question did say, write down Jeremy's route. Okay, so we're going to work our way back through this route. So what does it relate to? We were at 0, 0. And the best one there was action 1, so that must have taken us to 1, 1. At 1, 1, it was action 1 as well. That was the best one. So that must be 2, 1 that we're looking at next. In 2, 1, it was action 0, so that is 3, 0. And 3, 0, it was action 0, so that is 4, 0. But actually that's not enough, is it? Because the question wanted it in terms of the letters that represented the tones. So 0, 0 was J, 1, 1 was L, 2, 1 was N, 3, 0 was R, and 4, 0 was, oh, that was J again, wasn't it? Back at the beginning. So that's that. And our total is 13. There we go. And that was the 10 marks for doing all of that. But you can see how important it is that you just work through this logically. That it was frustrating if you didn't get the headings right, because that's the bit you've got to just remember. Stage, state, action, working. And they're the headings for that. Right, and that's maths.